live, but I will start the recording only in a minute.
And the other thing I think that's also really hot, just outside of politics, is tech in a recession right now?
I think not yet.
Yeah, so this is a very interesting thing, right? So I think if you're a new college graduate, I think it's very tough. But I also think the new college graduates, they over um their expectations of making business impact is way too high, right? Their expectation of them just graduating and making 200,000 is uh, is in a certain way just ludicrous. So it's very hard because they thought they were sold into a vision, which is like, oh, I just do good in school and then I'll make 200,000. And I think that, you know, you have to understand that you have to bring in typically 3 to 5x worth of value in order to justify your income. So if you are asking for $200,000, you must be bringing in $600,000 worth of revenue to the company, right? Because the company has to pay for, you know, facilities, it has to pay for benefits, it has to pay for the profit or whatever, the product and the everything, right? So I just don't think everybody is bringing that type of value. There are some, but I don't think the general public, because everybody that I've met that's a typical college student, I have not been impressed by their skills. Right? They're taught only academics and they have no real knowledge of how systems work. So I think if you have a good resume and you've done like real contributions. Oh, here we go.
Here we go, Albert. I think we are almost good to go. So you should be able to share that other link in your network and my network.
All right.
I will just...
I'm going to post right now.
And I can repost it. With that being said, Albert, for the video that I shared with you, did you check it out? What do you think about the AI generation?
Oh, the current there's a couple of videos in the current YouTube account.
No, I sent you one on Signal last night.
Oh,
basically I was using some AI generator to make...
I only saw, how Spark revolutionized big data. You're talking about this one?
No, in Signal I sent you a video file, and it was actually the first question that we want to talk about today. And I was just exploring, how does it look like if the video is generated from AI. Let me reshare the link.
Yeah, I didn't see. Oh, okay.
You got to check this briefly.
I have not seen it. I have not watched it yet. I'll watch it later.
Because I wanted to ask you, like, do you want to go live, or let we take the AI do the first thing and we just edit it?
George, you don't have to ask my permission. Yeah, I think you could just do what you want to go do. We try it, right?
Yeah, but you definitely have to check out the AI video, Albert. I'm really curious what you think about it. But for today, we are here live, actually public now.
Well, cool.
Let me kick in the recording. So from now on, we can basically edit stuff later. And if I get, should I repost it? What
I
you
just
sent
posted it in mine.
in LinkedIn?
I just did it in LinkedIn.
I will repost it. Let's see what happens. We will share and check out the stats later.
Well, it's just us two right now, so it's fine, right?
Yes,
Everything starts small.
exactly. We
All
wanted to
right.
go over the questions, right?
Yeah, or we could just talk, right? So I think if we, originally I think we wanted to go talk about is the state of data engineering, and our first topic today was really around data lake houses, right? So I think the first part is first is what is a data lake house? I mean, how would you describe what is a data lake house?
I think it's a deconstructed version of a data warehouse. So it's a bit more like SharePoint, right? You have a bunch of files. That was the big data era. But when people realize just having the random SharePoint folder doesn't help us, especially not if it's a gigantic amount of petabytes of data. And then, in the advent of the data lake, more and more metadata has been added to make it more clear how to deal with this data efficiently at scale.
Okay, right. So I would respond with it in two different ways, right? I think for people who are traditionally Hadoop users, this is the next version of Hadoop, right? Because Hadoop, you stored a bunch of files, you were able to do queries against the data, but the nice thing was like it stored a lot of data, but it was very slow, and HDFS was very hard to go and configure, right? Data lake houses, are easier from that standpoint. All
Yeah,
areas.
especially for streaming, right?
Yes, especially for streaming, especially for transaction ability, right? So for Hadoop users, I don't understand why are you still on Hadoop today, right? It's 20 years technology. Data lake houses is the modern version of that like Hadoop concept. So I think there's that. But then there's the second type of people who never adopted Hadoop, right? And they're like, why would I adopt anything that's a data lake house? And I would say, like, first of all, is most people use S3 for archival reasons, right? So I'll just store the Parquet file right there and I'll just query it, right? But here's the problem with it is that when you store the data, right, what happens when you have multiple writers? What happens when you want to do anything that's ACID, right? So the bad thing about it is that people design this kind of like, oh, single writer, it'll write the archive, everybody just reads, right? And that's great for certain use cases, but what if you want to have multiple readers, multiple writers? You can't do that, right? It's like having your MP3 collection, and you're just basically, saving this one file in there, saving another file in there, and if there's like if you made a change to one of those files, everybody would overwrite each other, right? It just doesn't work very well. So to me, technically, data lake houses provide database like abilities instead of just a file share, right? Which is what most people has been using S3 for. All right, so the assumption here is, first of all, is do you think that data lake houses, do you need a lot of data in order to get value from it?
Well, I mean, if your data is very small, you might get by with a traditional Postgres engine on a single server, let's say Hetzner or Fly.io or something. And there's less complexity involved. But for many large organizations, they have so much complexity already, and when trying to simplify, perhaps centralize this on a sane and open data platform can make a lot of sense. And that doesn't mean you have to look into the direction of Hadoop, right? If your data is small, or if at least it is small per partition of the data, you can totally go all in with DuckDB and maybe AWS Lambda,
Yeah,
and
yeah.
really have a cheap version of a lake that is super efficient.
So what is small then? Would how much can you define what is small? How many, gigabytes or terabytes would you consider as small?
I think this is not the right question to ask here. Like, as I said before, with DuckDB and AWS Lambda, you can even start very small and get over to very big easily. It's not about the size of the data, it's about the size of the complexity, more or less. So if you have a single server on-premise, then you will probably start there in your Postgres. But if you're anyways already in the cloud, then by all means start with S3, some Lambda and some DuckDB, and it's very easy to process a ton of data, especially if you partition it right.
All right, all right. Okay, so I'll give us some thoughts on that too, right? So the reason why I asked that was that I think small is what can be hosted on a single node, right? So like EC2, I think it's 16 terabytes, 32 terabytes, right? And if you run, I mean, it's not efficient, it's not cost efficient for you to run a 16 or 32 gigabyte node. But if you had like less than 10 terabytes, I think you can store everything on a single node, and then you can run, DuckDB on it, right? And then given your point is that you can move this out of EBS and then store it on S3, and then you're going to get that huge cost savings, right? I think it's like $1 of EBS to it's like only 5 or 7 cents for to store the same amount of data on S3, right? So you're going to get that huge value, more complexity a little bit because you don't. It's remote storage, but God, like guys, we know SANs, so it's not like EBS isn't a remote storage either.
And it's not only this, right? There's also the topic of backups. So when you have a single point of failure, single machine, someone still has to take care of it and do the backups.
Yeah.
And with S3, AWS is at least taking care that the thing doesn't go down. When you only on the logical level have to make sure that backups work,
Yeah,
not on the physical level.
And even though we're talking also about AWS, it doesn't have to be AWS, right? GCP has their own version of S3. Azure has it. You can run it on-prem with or your own environment with Ceph or MinIO. So there's a lot of options even within the S3 protocol world, right? So I don't think
Totally.
I don't think that's the lock there. In fact, I would even argue, I mean, I have a little Synology, like I have my own little like setup at home, and I can run even a object store on that as a way to more easily serve like even my MP3 collection, right? Even though that's not quote unquote data, right? Like what we think of relational
But I
data.
think that's a great topic, right? Because you want to find the right tracks from the particular artist. So you need to have some kind of governance. What governance and compliance challenges do we have to deal with in the Lakehouse, Albert?
Yeah, so that's actually a good point, right? Because when people think about typically governance, they always think about is like who has access to the data and who can read the data, right? And when you're at home, especially for the MP3 collection, you're not caring this about it as much. But when you're at a big company, I think this really is a concern because you hear all of these network breaches, like so and so company, they stole some intellectual property asset and then took it to another company, right? And so depending on your security stance, right? Do you consider what type of data in your organization do you think is valuable, right? uh, I would argue that before it used to be a lot of like documents that were important and whatnot, but now with AI/ML, the raw data, the data that's used to train models, is probably some of the most valuable data that you have. And so when you think about all this historical data that you've stored over time, so if you're an e-commerce customer, maybe it's clickstream data, or it is order data, or it's like what's been left in the shopping cart, or
Exactly, for
yeah,
supermarkets, right?
all that data that was nearly worthless. And the reason why it was like this whole thing was around like, well, the problem with data warehouses in the past is that we only stored summarized data, right? We never cared about the raw, right? So what I meant by that is like, okay, yeah, like the executives only want to know how much sales that we did at the month or at the week or by product category, right? But if you and they only cared that last 5% of generated data, right? But you had to have the whole 100% raw first, and then it goes to, for people who are not familiar, medallion architecture. You take the raws, then you create a new summary of the data, and then you summarize it some more, joining with other data, and then that's like 5% or 1% of the original size of the data, right? And the problem was that when you do AI ML, you cannot do AI ML on summarized data. It's nearly worthless from that standpoint. You have to go and store the raws, but in 5 years ago, no one would store the raws, right? It was like, why would I store this? Like, we're never going to use this. Once we have the summarized data, we're going to throw it away, right? I mean, I do it with, like, think about it, like even your own home. You get sent so many bills and all these pieces of sheets, and once I just file it for my taxes, I just throw away the piece of paper. Just imagine that the government kind of said, "Oh well, you know what? We're going to give retroactive like discount if you had a certain category of healthcare things that were done, or whatever it is, or certain categories are now tax exempt, right?" And then everybody's like, "Well, I threw away all the paperwork, right? I threw away all the raw data," and so it's the
I
same sort of
mean, on the opposite side, like when big data started, people were just storing any, even crappy data into their systems. And the vendors were telling them it's cheap to store, right?
Yes, yes.
And then eventually people realized that cheap at scale turns into costly. I mean, it was much larger than their traditional Oracle or whatever, but it was so large that it was again costly. But I think the worst part of it was not a data lake, but more data swamp, right? They couldn't find anything there
Yeah, they
because
couldn't
there was
find
not enough governance.
maybe not enough governance, or not even enough to imagine the creativity of the business model, right? So I always think about the story around is like whether companies like Uber could have survived in a different decade, right? So Uber, you think about it, it was a perfect combination of certain things. It was the availability of 3G and 4G technology. And there was enough processing in your phone in order for you to be able to receive messages, job requests, and along for you to do payments, right? And so the problem was that it was a good idea in the past to store data, but we didn't have the technology to take advantage of the data, right? And now you see all these newer companies like OpenAI and whatnot showing the possibility of you unlocking it, right? Um, so I take another point is that I used to work in the insurance industry, right? And if you look at traditional insurance, they would go and fill out this huge questionnaire, like maybe 10 pages, to sort of say, hey, what type of business do you have? What are your opening hours? Do you have valet parking? So they did some statistical model about this, and they said if you open a restaurant later than 8 or 9 o'clock, your chances of robbery skyrocket, right? And they also said that statistical models say that if you actually have valet parking, right, the chances of you having accidents in the parking lot dramatically increase. And so, the what I'm saying is that, there used to be actuaries that would go and create these kind of interesting statistics and say, okay, if you do this type of business, we're going to charge you much more. And then the IT industry with VC funding said, okay, we're just going to lump everybody together and statistically, okay, all I need to know is your zip code, because we're going to use high end, like these generalized models to go and do this. So this is where like companies like Lemonade do it. right? They only ask like 3 questions, and then they give you a quote, right? Because the idea is like I can kind of bury it under the model, right? And what they're finding on out, I think, is that the actuaries were right? Meaning that it is cheaper for you if you really know what specific conditions are. You can make a lot more money. But the problem is actuarials are finding people to do it is expensive. So doing this kind of like generic model is cheaper for the internet scale. But if you had that plus AI ML models, now you can make a actuarial as a AAML model and be able to do all the old things and the new things, right? Um, and I think businesses that get launched in that area is very interesting, right? So I would say that part of insurance is called PNC, property casual industry. Pet insurance is another big one, right? Uh, People asked me around when I was doing pet insurance type work, they were asking me, why is it that there's only a single cost? And I said that there is not enough raw data to actually generate is the cost. Because you think about it, the largest chains in the United States is what's it called, VCA and Banfield. And Banfield, I think, is only 600 locations. So the problem is when you have 600 locations, you have maybe more data for you to say, hey, this type of breed is more likely in certain areas to have much, much more health issues, right? Versus other places like most veterinary practices are only a single location, 2 or 3 even locations. And that's even very large. So you compare to, they don't have a large statistical model for them to be able to go do things, and that's why they can't be able to easily go and calculate, the cost of insurance or cost of for you to go and work in that area. So. But veterinary practices have all this data. They just don't know how to leverage it, right? Um, Anyways, that's maybe going off a little bit track about insurances and statistical models and
A bit, but I think a key factor that you just glossed over was the basically VC funding, the era of cheap money, right? And that sort of came to an halt with COVID, basically.
Yeah, I think cheap money is very funny. Obviously now you have to be much smarter about the way you do things. Um, and it's also kind of like it's harder to make money, right? So um like here the in Southern California, the standard way of making money is by commercial property, right? You get a 30-year lease on it. You could do deprecation and whatnot. And a lot of people bought is like, pizza parlors, and I would say is car washes, right? So it used to be car washes, cash-based business, wonderful for that standpoint. Every car would come on in, $30, $40 for you to wash the car and whatnot. And then now it's like now there's a bunch of like I think VC funded companies who are buying up old pieces of land and or old washing machines, and they're doing a subscription model, and these places are killing the custom one. But I say this is that people are not doing anything revolutionary. They're just This is just making it a little bit more difficult for them to make more money today. But the guys I think that are going to make a killing are the ones that can go and apply some interesting statistical model on top of that data. Like for instance, um, I read in another report is that when a Starbucks gets opened on up, the values in that area generally move on up 5%, right? And so if the idea here, if I was a real estate investor, I would go and say, where are the new Starbucks being opened on up? And I'm going to be buying property in that area, right? If there's Starbucks that are closing, then Because you think about it, so how Starbucks works is that they have a property team that basically searches all the best locations all around United States, and then finding out, oh, is it, do they have in that area, do they have is revenue to support uh, a Starbucks store, and how much money are they going to make from that Starbucks store, right? So they find all these locations. They don't just randomly put a Starbucks wherever they think that is, right? There's some data, there's some statistician that is actually saying that this is the ideal spots for them to go do it, right? But once they put it, generally speaking, I think they do get it right, right? Uh, and but it's like is using that heuristic of just buying where a Starbucks opened up is enough? Would it be? Are there other cofactors that would make it that it's an ideal place for you to invest and spend money? Right? I don't
Tricky
know.
question.
Yeah, even as us, right? As like, so on the side, I do investments, right? And I also tried to go and play around with this like heuristic, right? So I invested in like a Popeyes chicken, right? And this is down in Florida. And Popeyes chicken, okay, among American fried chicken places, like I would say Popeyes is number one in my mind, right? Uh, KFC in other countries is good, but KFC in the United States is horrible nowadays, right? And I thought it was a sure thing. So you buy a Popeyes, you invest in a Popeyes franchise. They take about like a year and a half to get through city planning and get built. That investment I lost all my money on, right? So it may be not just enough to have a good brand, right? And it was like a good location. This is the South. People tend to be a little bit more overweight. They like fried chicken. Yeah, so I can't say the heuristic is totally correct. um, how about in Europe? What are you seeing in Europe that is like interesting? I know we're kind of moving off of data, data lakes itself, but it's really, this is more of a statistical analytics problem, right? What do you see in Europe?
The challenges with the war topic,
Yeah, well,
but also money being way harder to attain for startups.
very hard to attain. You know what? So I heard this whole thing is that the main problem is because Germans put into, or Europeans put into a lot of their constitutions to never go negative on incomes, right? And the problem here is that you got to invest and lose money for a couple of years to gain back money. You can't be just like, oh, well, it's like, zero, right? It's like zero risk. Like you can only play with your profits, right? And I think the problem is that you can't take advantage of timing, right? Um, but that also means you can lose a lot of money too, right? So,
You can only make bets.
yeah, well, and you can only make bets like, I hate to say it, but Americans are like, we're kind of like, we really love this underdog story, and we're funding like some like risk and reward, right? So even in the VC market, they're like, they consider, even say for instance you invest in 20 companies and all 20 companies make money, they only consider success if one becomes a unicorn. All the others, they think it's a waste of money, even though it's a great business and it still makes money, but it just doesn't make the unicorn type of money, which is kind of really funny, which is like most people would be very happy for 20 successful businesses that are cash flow positive. But Americans don't think that's good enough, right? You have to be like some type of, gangbusters from that standpoint, right?
I mean, the interesting question is also, can the economy always grow? Because this is the assumption, right, behind that model.
Yeah, that's also a really interesting point. It's like, but we are off the gold, standard. All countries essentially are off the gold standard. So theoretically, this is funny money backed by a quote unquote U.S. military or any other type of faith based thing, right? Uh, and so theoretically, it's limitless. And who actually owns the debt? it's the people who actually own the debt on a promise of an IOU, right? And if you look at it, is the savings is not even physical savings, they're reinvested in other ways, right? So even if you have a bond, the bond's bought other physical things, right? Or it's been used for something already, right? So this idea that there is unlimited growth, I think this is you know, a mental limitation about how humans think about something, right? So, but we can manage this perception of 2% growth. Um, and if there was something that could disrupt the entire industry, you know, um, will we change our monetary policy? It's interesting. I mean, I'm not a monetary person from that standpoint, right? But I still feel like there is a lot of business opportunities. Just the question becomes is where we spend the time in, and how much of it is something that you want to go and do, right? Um, I I think so. For most people, we can probably get to quote unquote middle class. It's a little tougher now, but how rich do we want to be, right? And what do we want? Is it something we want to go do? Like most of you hear these startup founders that they became rich, and but it wasn't their first or second or third or fourth idea. Some of them have done it for a very, very long time, and some of them switched a long time. And I wonder if that's really what they wanted to work on, or is it because they kind of was okay and it started making money, right? You get trapped into this making money part.
I
Um,
think people start with a vision and they really believe into that, solving that problem, because otherwise they're not strong enough to push through when things don't work out 3, 5 times.
yeah, it's very tough. You look at so the guy who sold MailChimp, right, started his company I think 2001, and he eventually sold it out for I think $15 billion to Intuit. And And his big thing was that he never took VC money, and he always said to his employees that, I'm not going to go and sell on out. Eventually, he did sell on out, uh, but he had this strong vision of, just ownership and just keeping and improving the product. And he's one of the few, I think, that still kept on doing it, right? But you look at something like Roblox, right? Roblox started, the guy who built Roblox, he wanted actually is a website to teach physics, and he built it, and then he said like, well, wouldn't it be a better way is if I showed physics or taught physics. He had no users apparently, this site or like this thing, and nobody wanted to learn physics, right? And he says, what if I built a game world which had physics in there? And that's the idea of how he launched Roblox, right? And it wasn't popular for 15, 10 some years until COVID happened, and the right situation where just all these kids were just stuck at home, and then they had to play with this, then they had this like, oh, play with this kind of, physics world, right? And that's how he got, to be worth what, billionaire, right? And so these guys who've worked on this like singular idea for a very long time, I'm like amazed for them to be able to keep on doing it. And then there's the other guys that just, pivot to a new idea until they find something that they get famous for, and then they just stop doing it. And then there's some people who like I think there was another article about Steam, right? That the guy is a multi-billionaire now, right? The guy who created Half-Life and whatnot, but he doesn't build games anymore. Like he got famous for building games, and then he made a lot of money. Steam as a platform to go and resell. He became now a distribution network, and he hasn't built any game anymore, right? And so I feel kind of sad versus like the guys who built Blizzard, right? So apparently, they sold on out to Activision, right? And now Blizzard is not exactly the same Blizzard that I knew when I was younger, right? When my early 20s. But that Blizzard, some of the founders who sold on out, they are funding a brand new game that is a combination of playing on your iPad and playing on a screen jointly, right? So this idea of like, I don't know if you know the game Gloomhaven. Have you ever played this game Gloomhaven before?
No, I'm not an expert there, totally not.
No, no. Okay, so I used to go and do board game conventions, and so I used to try to, you know, I'm not very good at Catan, although there is always the world qualifiers in LA, and I never really did very, very well. And my favorite game is a German Euro game called Power Grid. I don't know if you've ever played it, but it's wonderful. It's a brain burner. But Gloomhaven is a think of it as a lightweight Dungeons and Dragons. There's some pre-built scenarios, and there's like, characters you can move on a board, right? But basically, they're trying to build is a iPad / digital version of this world, but it's not. But it's there. There's more of this physical element instead of just pure just playing as a RPG online, right? And I thought that was very, very interesting. Where that's the thing. Like I love like tech for the sake of tech. People ask me like, "Oh, Albert, you've been doing this for 20 some years. Like, what happens if you get rich?" I said, "I'd be still doing this. I love tech for the standpoint, right? My graduating class in computer science in UC Irvine, this was back in 2001. My graduating class was 120 of us, right? And I thought it was great. You spend the time writing code, playing video games, and then writing more code and playing video games, right? And that was the wonderful time. But now it seems like it's just a business, right? Back then, people who did computer science really just loved computer science, right? Or loved the aspects of computer science. And now it's like, oh yeah, like there's like, I want to make 200K, and so I'll just do computer science, even though I hate computer science, right? And I'm like, I get it. You want to make money. Money drives everything else, right? And if you had money, would you still go do it? And I think it's an interesting question to ask a lot of people.
And alongside, we have also the bootcamp topic, right?
Oh yeah.
But before we get too lost there, Albert, you mentioned physics, and I think the rule of physics always play a big part also in computer science, and how organizations are structured. So in the past, like with databases, people tended to do authorization right in the BI app. But when looking back at what happened with Lakehouse, it was changed to now happen on the storage layer.
Yes.
Do you think this was a good thing?
I think it is. I think so to me, a database has two pieces, right? There's the interface, which we think is really the query engine and the SQL language or any other language that you interact, right? And then there's the real storage of the data, right? So to me, storage is not just storing the raw data, but also organizing the data, like using an index or a partition. And there are other features to go and organize it itself, right? Because you think about it, is like, so there's these two pieces, right? And if we talk about the 20 years of disaggregation of the traditional database, right? Traditionally, these two pieces were built on top of each other and combined as one unit. And now we are seeing that there's separation of the query engine and the storage itself. And so should access controls be on, only on the query layer, or should it also be on storage, or should it be a combination of both, right? Traditionally, I think what's going to happen here is that each one is going to take that security, and they're going to have different roles and responsibilities. Right?
I mean, there's dynamic data masking, right? And
Yes.
that is super convenient, but doesn't work alone only from the storage side. There has to be some interplay.
Yeah, there has to be some interplay from that standpoint, right? Like Parquet has also encryption that it's built on in, but that isn't enough, meaning that, who owns KMS? Who owns the key management, right? Is it really
DevOps.
like outside of the system? Is it like, should it be stored as part of the system in storage? Should it be managed by the query layer? Because there's different types of ways to do it, right?
And there's even the EKMS topic, right? Where you don't trust the cloud provider,
Yeah,
but
you
you
don't.
have your own external system.
Exactly, right. And I think so. There's also this whole talk. It's been out for a little bit, but used to be there was like zero trust security systems where there's a whole I think there's a whole branch of mathematics and even products that are trying to build this how can you trust without knowing the other party, right? But still, this idea of security on the storage layer, security on the query layer, I think both layers are going to have it. If you look at what people are doing right now, I see Apache Ranger as the most popular way to secure is the storage layer, right?
But
However,
also in the cloud-based scenario, I know it very well from Cloudera and on-prem.
yeah. So they're trying to apply that. I know that StarRocks, for instance, supports Ranger as a mechanism to go and secure the data itself, the data files themselves, or access to the data files. But rumor is that this security layer is going to be moved into the catalog layer, right? So now there's this bifurcation. So there's the query layer, there's the data catalog layer, and then there's the data storage layer. And now people are thinking that in the data catalog layer is going to happen. So Unity catalog, I think there was just a recent feature announcement that they are applying some type of RBAC system in that area. And that kind of makes sense because storage itself, is a bunch of files for all intents and purposes, right? But you don't know what exactly is in those files unless you scan all the metadata. And the aggregate metadata is all stored in the catalog, right? So people don't access the data directly. What I'm saying is that they go through a data catalog, right? And the data catalog says, oh, I need, customer records for ABCD, Acme Company, right? So they'll ask the data catalog to say, hey, give me records for ABCD. And it responds back to say, oh, you're looking at Parquet file 7351, whatever it is. And then you go directly to that file, right? Instead of scanning the full data. And so I can see why people are trying to secure is the catalog layer. And so that when you are using a query engine, when you ask for this, like I need Acme Company, the catalog will just either accept or reject, right? And it'll actually even know theoretically which KMSs are actually being used against that Parquet file or Avro file or whatever file it is, right?
But for this to work, we would need an open standard, right? For the file-based authorization, for the catalog authorization, and for the dynamic data masking. So all these three would need to interplay.
Yes, and I don't foresee any of them that is going to happen.
And I think you're not alone here. Like if you look at Google and what they are doing with BigQuery and Iceberg, they have their own version of Iceberg, right? And all the interfaces is a sort of safeguarded by Google.
Yes.
So
yes.
it's again a sort of lock-in factor, but only then they can guarantee that it works and that the security measures are actually applied when reading with Spark from BigQuery via Iceberg.
Yes. And so I can't say, but there is some other work, and I can't name it yet because it's not announced. And I think it's going to address that specific issue. Because reality-wise is that everybody has a domain to protect. Usually standards, if you look at how open standards kind of work, they're either done as a way to there usually is like an incumbent that dominates the market, and then the smaller companies get together and then build an open standard to force the incumbent to kind of be less dominating, right? That's one way to go do it. Another one that you have is commoditization of an existing technology, right? uh, there are some places where a new standard gets introduced, but the problem becomes is like it's hard to get adoption, right? It's much more easier for you to go and say, I use an open standard to dominate is a specific tech area. And this is kind of like the same thing with what happened with you know a Delta Lake, right? Delta Lake says, hey, I'm an open source project, although the top 30 committers are Databricks employees, right? So, is it really open source? Yeah, it's open source, but the thing is, can you contribute? Well, that's a different question of whether or not it's open source, right? So, I think these I would say software moats are going to constantly appear, and now the software moats are appearing in the data catalog layer. Uh, and that's why you hear this whole thing about like, hey, are we Unity? Are we Polaris? Are we whatever it is, right? Uh, which I think is, it was bound to go happen. Uh, but then we're also missing some of the other picture of even just like the I get this kind of comment that from other people, oh, the open table format wars are done, right? Iceberg already won, right? And uh it's one of those things where I think like, is Unity, it's the same thing, is Unity going to win, is Polaris going to win, right? I don't think it's going to be a situation. I think there's going to be winners in both camps. There's going to be users in both camps. It's the same thing for open table formats. It's not going to be one rules for all, right? So like Iceberg was designed primarily for heavy reading workloads to drive BI dashboards, right? Hoodie was designed to be a transactional streaming workload where you're updating data and you're querying data in real time. Heavy read, heavy write. uh, and they're fundamentally different because of how they implemented the technology underneath. And people kind of like hand wavy wise, this is, oh yeah, Iceberg does merges, and I'm like, it's not doing the same type of merge that you are thinking of. Fundamentally still is that it's rewriting the entire like parquet file from that standpoint. Or they use some type of little thing like, so Iceberg does is basically positional deletes, which are, yeah, you could argue that's merge on read, but positional deletes doesn't mean that they are solving still for updates and inserts, right?
But you're not referring to merge on read versus merge on write here, right?
Yeah.
Something more nuanced.
Yeah, well, see, that's the thing. Is like you've got the people confuse is the process along with the table type underneath, right? So when you talk about merge on read, it really is a way for you to go and says, hey, I want to be able to read a sequence of files, and then construct is the data set that's coming back to you, right? So when you do like positional deletes, right? I want to do a delete, right? You're basically looking at one file that says, uh, delete this, don't read this, don't read don't read these rows, don't read these rows. And then you see the bottom base, which is like the full data set of 100 rows, and so you're eliminating certain rows out of that set. That's merge on read, but that's not performance still, because you could have 100 of these positional delete files, right? You're not reading one file. It's
And would
still
deltas deletion vectors, Albert, would they be better?
Yeah. So the thing is that so each one has pros and cons, right? But I think what I'm trying to go say is that ultimately the only way you're going to get real great performance is that you have to consolidate all these positional delete files or positional metadata all back down to a single file, right? because every single time you have all these different files, it's IOPS. You have to do input output. You have to do if statements. You have to go and process it.
Okay, so someone has to do the housekeeping.
Yeah, someone has to go and do it, right? And essentially, and what people don't realize is that in normal databases like your Snowflakes of the world, or even Postgres, or MySQLs of the world, they all do this underneath the covers. I call this like defragging the data, right? People, the idea here is like, oh, I'm gonna just store stuff on my computer, and then I never need to worry about it from that standpoint, right? And I'm like going, no, the concept here has always been like, you always have maybe like, we as gamers, and just going back, not out of a database person, as a gamer, you kind of know how you get better performance, right? You just defrag the hard drive, right? Because when you write the game files on your system, they're sometimes out of order, and you're not going to get that same type of thing. The first thing any old school gamer will tell you is like, okay, like, yes, you've got to first, do you have the right video card? Do you have like the right CPU? If all those things are done, fundamentally, your game files need to be defragged, and once you defrag them, then you're going to get much better performance, right? So we do all these things on the data layer of like kind of like rewriting SQL statements, doing doing caching, doing materialized views, right? But if the data fundamentally underneath is not written correctly, like it's not using, it's like it could, is it using Z order, Hilbert curve, linear data layout? Is it reading multiple files in order to get the query? Is that, are they consolidating? Are they consolidating the metadata, rewriting all the data to be consistent, right? If all those basic things are not done, you're not going to get the most performance system.
And how good are humans at fine-tuning the data layout at disk? Like understanding the parameters like file sizes, data skew in the partitions. Is there something more automatic available?
Yeah, so there is no easy way to go do it. There's not a lot of tools that are around it that we or people get exposed to it. So the only software that I know that's free that does it is OneHouse Data Lake, Data View. And it's a free service, but they only offer it currently for hoodie users. And basically they read all the metadata, and you can go and see what type of data. And if you change the layout strategy, then you can see a before and after of how the data looks. But the caveat is this, is that when you change the data layout from like linear to Z order or to Hilbert curve, you have to rewrite the Parquet file. There is no way around it, right? And for people who are not aware of data layout, think about it as this, right? So when you write data, right, when you do a select statement where, right, you're only along a single dimension, right? And then when you do a lot of other predicates, adding more where clauses on in, right? Now the thing is that you're shaping a query that is more in multi-dimensional space, right? And when you think of multi-dimensional space, is that you're trying to make a query that is maybe a circle within a three-dimensional space, right? And what you want to do is you want to order the data or write the data in such a way that they're close to each other. And that's what Hilbert and Z order, Z curve does, is that it reorders and rewrites the data in such a way that when you do multiple predicates, multiple where clauses, in certain situations, it's much more faster and much more efficient. And
but why were people not thinking about this in the traditional Oracle or Postgres system? Like it was batteries included, it was defragmented by the system.
Yeah,
but it was automatic. Like you just said, create index, and then it worked.
It just worked because, you know what, we hide a lot of, one thing in computer science that we do is we do so many levels of abstraction, right? And so I always joke about this in computer science. It's like, when you say like 9 plus 7, and on your programming, you actually write this in Python. It's just one line of code. Have you ever seen what a plus two numbers is in assembly? It's like 20 lines of code to just do the same thing, right? And I say like that one line of 9 plus 7 that you think is, oh yeah, it's simple. 9 plus 7, 16. I'm like going, yeah, do this in in base 2, and then you're flipping registers to get this to go and work, right? That's the same thing in we hear in data, right? It's these guys who say, "Oh, my SQL is so optimized," and I'm like going, "You know that there is a cost-based optimizer that runs behind the scenes. So no matter what you write, it's gonna break up that query and then rewrite it to what it thinks is most efficient." Right, so these guys who spend like I joke about it, spend hours writing the special SQL query, and I'm like going, you know what? Good for you. But you may not be getting what you really think about, because that's not really how the engine works underneath. But we abstracted it away so that you think it's going to do something, right? So it's kind of interesting. It's an interesting topic, and so as you as data engineers that really are deep dive into it, I think this is the difference between some people who have theoretical knowledge and then people who have just like, I only use a product. And this is the same problem I have. We were talking a little bit about like these people who go to 6-week boot camp, right? And I asked them basic algorithm questions, right? I said, like, so, what's the difference between a bubble sort and a quick sort, right? And they're like, what? Like, what? What's so important, right? It's both of them are just for loops from that standpoint. Oh, I was like, yeah, both of them are for loops, but how you do it and insertion time, lookup time are very, very different, right? And they're like, what? I don't get it, right? It's like, and then you have to build it out on Lego, like blocks, and see the visualization of how the algorithm works. And they're like, oh, that's really what happens underneath. I say, yeah, that's why it's so important for you to pick the right data structure and the right algorithm for your given problem, right? Not just say, put everything in an array, not put everything in a hash table or map, or everything in a linked list, right? There's pros and cons to every single structure, just like I say, like this. But most people, they don't. They're like, I got an object that can basically store anything, and whenever I just do add more data, somehow it still works, right? Even though they might have to rewrite the entire data structure underneath, like an array. When you do array expansion, right? Literally, like, if you wanted to make the array bigger, you have to go and create a brand new array of a bigger size and then copy all the individual elements and then add one, right? As opposed to if you had a linked list, you can just add that extra node on top of it. So, we get into these really fundamental things, and I think a lot of people glaze over it. So this data layout, it's like, it's also a conversation too, is does their manager even know, or their CFO knows, or tech people know? A lot of people just say, hey, oh, yeah, you're getting bigger query performance, but you're going to have to just pay more in VMs. Like, that's, or more, a bigger VM is, that's their answer, right? Because they don't understand like underneath what they're really doing. They just say, just do this, right?
At least it's not row-based layout, right?
Yeah. So, and who is the guy who really knows, right? I mean, yeah, we also get to the idea of fundamental trust, right? It's like the same guy who's your plumber or someone who's your general contractor who's building your house. How do you know? Like, we're not civil engineers. Like, how do we know that they actually did it right and correct, right? And a lot of times we just only look at cost, and we're like, oh, this guy came on over, he fixed my thing for my plumbing issue for $200. He was the cheapest guy and whatnot, and maybe all he did from that standpoint was just run Drano or run run, like you know, uh, actually there's this special thing. It's like sulfide, whatever it is, but basically you pour this powder in there, uh, and then you run hot water, and it basically creates a lot of heat and gas, and it will basically blow up any like obstruction or like fats that have been kind of
Yeah.
like it's like, and I'm like, the funny thing is this, that little bottle is like $6 online. But the thing is that Home Depot is happy to sell you the $30 bottle that's a liquid version of it. If you get the powder version, you only have to pay $6. But it's only the people that are plumbers who knew that. And the only reason why I knew is that I asked a plumber about how you fix this stuff. He goes, Albert, there's a lot of things in the plumbing business that normal homeowners don't know about, but we just sell them the $30 one because we make more money and we can charge for it, right? And but if you know a guy and he tells you what's the real fix, it's only $6 and you can go get it, but you have to ask, you have to know exactly what you asked for, right?
But it's easier to ask, right? Because it's a physical thing, and especially with data that is sometimes detached from the core business process, it is super hard to see the impact. And it's virtual, right?
Yeah, it is. It
And in
definitely is.
principle, you would want to listen to the concert of a real rock star, right? You would
Yes.
want to have a data architecture constructed from a person who's a proper engineer or perhaps architect, and not just by convergence to the mean like a democracy.
Yes. So the I think it comes down to is kind of like trust and knowledge, right? It's the people. What's it called? What's that principle? The people who are don't know anything are the loudest typically, and then people who are loud also may be also smart too. Like it's really like some of the best engineers that I know of are very very silent people, and they don't like to you know. Um, upset or they don't want to push the apple cart because you think about it, human behavior, we've survived as a society because we just get along with everybody. Because if you're a hunter gatherer society, you can survive if everybody works together and there are no frictions from that standpoint, right? And someone who proposes something a little bit different, that different, even though it may be better, is considered like, oh well, you're disturbing the peace for everybody else. And so the people who really do know something, even though we may say something, right, uh maybe that's just not something that they want to go hear, right? Like think about it as going back to that plumber or general contractor, and he says like, look, you know like this bathroom or this wall has termite damage or the pipes are really really bad, so I can fix it for $200, but you're going to call me again in a month or 2 months time to fix something else with it, or we can spend $5,000-6,000 to replace the entire plumbing, right? And the guy is probably saying like, it will even take me more time for me to go and do the $5,000-6,000 job, but I know it's the right answer. And the problem is I hate to say it, but we're not necessarily incentivized to say the right answer, right? And the other guy, if they really trust you, that they want to go and do the right answers, because everybody thinks that there's such a low level of trust that maybe like I'm cheating you, right? Or I know better, or whatever it is, and it's very hard to make a convincing argument. Uh, so even to have this discussion, right? These people who say, um, "Oh, you know, uh, go back to linear," right? Everything is by default linear, right? And even if you bring up this discussion, they're like, "Oh, it's just too much risk for us to go try." Uh, and I said, like, look, I understand maybe you have a lot of data, so that's really hard to go do. Maybe do a small subset. They don't want to even do that, right? Or even if it's a small subset, a small amount of data, they don't even want to do it. Um, so I think it's trust is very tough. Trust is very tough. Um, I have no way other than to go and say, "Hey, look at the history of what we've done and how we've interacted, and would I be, um, you look at that as a way to project whether or not it's very good to go and do business with me. And this is a very interesting point. There's a I forgot there is a banking institution in the United States that gives loans to people, right? Now, traditionally in the United States, they do it by credit score, right? Which is very unique because not all the entire world has credit scores. But this bank or loaning, right? They actually loan you money based off what college and what major you graduated from. That's like the largest, like one of the largest parameters that they use to determine how much money that they loan at what interest rate to you, which I thought was a very interesting thing. And guess what school this came out of? Like this was funded. This VC idea was funded from. Guess what school it was funded from?
Well, maybe a well-known one like MIT, perhaps.
Stanford.
So the
Stanford,
economic
bunch of
guys.
Stanford guys got together, got VC money, says let's not base it off of credit scores. Let's base it off of what college you graduated from and what major, which I think is a pretty good heuristic. I mean, you think about it.
So did Stanford rank highest?
I think there's probably more than just Stanford. I think if you're probably in the top 50 public and private universities in the United States, that probably says a lot. And then what majors that you're in within it. I would probably say that, if you're in the hard sciences, you probably will get a better, your chances of defaulting on your loan are much lower, right, than someone else. But if you're a liberal arts major at Stanford or Yale or any of those schools, I don't think you're poor either. So, so I think your default rates are probably pretty low, right? Not zero, but it's definitely not as probably not as high as maybe a community college.
Albert, how did these default rates change with regard to security when comparing lake houses with a traditional means of securing data and data architecture?
Well, you think about, when you have a vertically integrated stack, you have a better way for you to go and do security in the sense of like it's only one product that you have to go and test against, right? And you can test against specific scenarios. When you have a data lake house, the idea is that since data and the query engine is separated, you have to test each individual product combination to make sure that they adhere to that standard. So this is the very big problem, is that even though the data lake formats provide its features, like for instance, Iceberg has a spec on view, but I do not know of any query engine that actually utilizes that spec as part of their queries, right? And you can also argue too, even on the Hoodie side, Hoodie has what they call as incremental queries and read optimized queries. And I have the support for those specific features inside of the data lake are varied, right? There's some vendors that support some of those features and other ones that don't support any of those features.
And what are the largest challenges with regard to security? Do I understand correct that this is the non-black box appliance, so that there are so many disaggregated pieces that need to be orchestrated?
Yeah, I would say that it's really more about is how they generally access the data. Like right now, for most data lakes, they would say that they need access to two different pieces. They need access to a data catalog and permissions to read and write in the S3 buckets. So if you take the more simplistic case where you're deploying on AWS, they would access the glue catalog, like a access and secret key to access that, and then another access and secret key to access the S3 buckets underneath. And they're generally relying on, other systems to go and provide that security. Like what I mentioned is like, oh, S3 underneath provides encryption at rest, right? So they're relying on that storage system to go do it, not necessary encryption within the Parquet file or data file itself. And I think this is going to be a maturity statement as data technology, data warehouse or data lakehouse technology improves. You're going to see more and more security, applied across the entire board. However, I think the bigger discussion is whether or not data lakehouse technology is going to be a thing, right? So security tends to lag compared to whether or not this technology is going to be beneficial, right? So the case in point here is like kind of like YouTube. YouTube used to, when it first started, was to, you know, basically have a lot of copyrighted material on video. And as time has gone on, they have cleaned up their act, right? And I feel like a lot of, technology or even applied use cases, that the happy path is can we first provide um, data lakehouse or benefits of storing lots of data, analytical data on things that doesn't need that level of security around the data, right? And then as time goes on, the technology matures, and then we move more and more workloads and do more and more different types of things to the data lakehouse, which then would requires a higher level of data security that's involved.
Yeah.
Um,
I mean, one clear advantage is this topic of streaming, right? But
mm,
with the Lakehouse, we have a possibility for interoperating batch and streaming systems on the same storage layer.
yeah, so I think this is the larger discussion about like what streaming is, right? So for data lakes and data warehouses, streaming is a very new concept for them, right? Because traditionally they did is scheduled batch workloads, right? And so typically you would ingest gigabytes of data and ingest it at one time. And this idea of moving to a Lambda type architecture where you're streaming data maybe one row at a time, right, is very, very difficult for systems to be able to go in and do. Because why? When you think about it, the reason why bulk works very well for analytical systems is because you can basically read a bunch of data, like say, for instance, a gigabyte of data at one time, and just do one process, one job, and write the brand new Parquet file. When you have these one message at a time, you're building basically a Parquet file with only one row in there, right? And so you have now thousands, hundreds, thousands of all these little small Parquet files. And now some of the Parquets you can send it, like there's like 100 rows or 1,000 rows. But that's not important. The important thing is that you're not writing is a single big file anymore. You're writing all these small files. And when you do a query against a system, you have to read all these small files and big files to get the query response on back. Um, and so this becomes is not optimal for a engine that was designed to basically say, hey, we're gonna, in order for us to be fast, we have to just read data and process data with as minimal IO option, minimal, IOPS, and be able to go and manipulate it as much memory as time, right?
But that also depends on the use case, right? For some use cases, copy on write is better versus for others, merge on read. What if we dive a little bit into this topic to make this clear when to choose which strategy?
Yeah, so copy on write implies is it literally is in the term copy on write, which is that when you are making a change to the file, you will go and write as a brand new clone of the existing file system, existing, Parquet file, and then make your changes on it. And the reason why you're doing this is that it's the idea is that I write once and I read many, many, many times, right? And I'm not reading a bunch of small files, I'm reading the final, right? So you think about this in use cases like data, dashboards and a lot of AI ML workloads. They pull the data on in. It may be hours late or maybe minutes late or whatnot, but you're able to go pull that data and then write it once so that you have reading, and it doesn't necessarily change very, very often. So you don't need to worry about having this write amplification. Um, this idea of constantly rewriting the file over and over. So
But if I'm streaming and I'm constantly writing the files, we would need a merge on read approach, right?
yes, yeah.
But when
So
do we optimize here and periodically compact the files to be still efficient? So I guess we have to combine them here at some point.
yeah, you have to combine at some point, right? So copy on write, optimize for read heavy, right? Merge on read is very good for balanced read and writes, heavy reads and heavy writes, right? So the question becomes is that when you're writing all these little files with merge on read, right, you have to schedule as compaction at some point. And so the question is, do you do it inline or you do it async? So if you do it inline, right, you're going to have a lot of writing that happens, right? Because every single new entry requires you to write a brand new, Parquet file or whatnot. And if you are, if you do it async, so every 5 or every 10, then that's at every 5 or 10, every 5 or 10 inserts, right? You think about that. You have the base Parquet, and then you have 9 deltas on top of it, right? After the 10th one, then this would be merging back into the main Parquet file. So now you're back to only one Parquet file and 0 deltas, right? And so this is a very optimal way for you to go be able to handle the small files problem. It's a very easy way for you to handle any delta changes, whatnot, because there's this constant of remerging back into the main file, and you get to go choose, right? Some systems from that standpoint force you only to go and do it inline, which is like so you're constantly remerging the entire time. Other systems do it all async, right? So that's why sometimes you see you know uh, I joke about it, but there's times when you see the database and sometimes it has like 5 CPU utilization happening. You're like, what the heck is happening? I'm not even using the database. And that's what that defragging is happening. That it's all that work to remerge the data, reorganize the data so it's much, much more optimal for the next query that happens, right? A lot of these things of the cleaning is it just gets delayed, right? Yeah, so yeah. So
Would it be possible to skip this, Albert? So if we say we have a zero ETL, zero copy architecture, could we skip the defragging and simply leave the data at the sources and be done with it?
yeah, so that is well, all those systems actually go and do defragging at some point, right? So the thing is that either you do it, defragging at a centralized location, or you do the defragging at those individual products itself. And then the question becomes is whether or not, you trust those systems, those smaller systems. Do they have a really good algorithm or a process to go and do that defragging, right? So I think with the idea of a data lake is that we don't want to have all these silos. So what do you get with the data lake, right? So all the data gets aggregated to a single quote unquote S3 location, right? Just so for simplicity's sake, right? And when we defrag all of that, now all the clients, all the query engines that use that data lake instantly get that, benefit from that standpoint. If we did it the other way, which is like we federate the data, Like we copy data from one data lake to other data lakes because why? Maybe because they require a different format or whatever it is, right? You've introduced what? You're not going to have as much data freshness because you have to wait for the synchronization to happen. You're not going to go and you're going to get extra work because you're going to have all these new pipelines that you have to write in order to move the data from the main location to other systems, right? And then the other thing too is that once it is in the other location, the other product has to go and ingest the data again and be able to go and reorganize the data. So you're basically paying all these penalties along the way. In the ideal world here, it would be just one location, all highly optimized, and then the clients just all get that data once, and then you eliminate the data pipelines, you eliminate the data freshness problem, you eliminate duplication of all these silos, duplication of all the other infrastructure needed to go support it, right? uh, it goes back to this whole idea of just keep it simple. Why can't everybody just use one copy of the data, right? And the classic argument is like, well, the data in the data lake is not in the format that I need, or it's not in the structure I need, or whatever it is, right? So that's why I need to make my own copy of it, right? And I said that, yeah, that traditionally happened because a lot of the engines themselves didn't support as an open table format. But now that there is a huge push for open table formats, like Snowflake does it, reads Iceberg, all these other companies now can read open table format. It really becomes a really difficult position to sort of say, I just need my own silo for my own thing, right? And then having those data engineers build it. And all of it has to be monitored, and all of it's brittle, right? You can argue that it's maybe not as brittle, and it's a way for us to give jobs to everybody, but but it's definitely not necessarily no one wants to be in that business.
But the jobs topic is for migration.
For
So you
my
always migrate to the next technology to keep the job or the
Yes,
team as a manager, right?
yes, yeah. So this is, yeah. You hit a good point. Is that at some point you're like, I need to keep these jobs up and running when I'm the only guy, and then this whole argument comes in to say, yeah, okay, you're the legacy team to go and keep this up and running. Some new vendor comes on in and says, either I'm going to build something better and brand new, and you don't have this legacy, or the number two thing is that you just get outsourced. It, I mean, that's how you would go and see it. It's not like the management is dumb, right? It's not like they don't attend conferences and they don't know what's going on. It's the question becomes, is like, is this the right time for us to take on this type of project, right?
Yeah. But I think in general, we both would agree that we are not living in an ideal situation. So we can't live in the world where we don't have to copy the data, but we do copy the data, and then we have to do the house cleaning, the defragging.
Yes.
And we mentioned already one potential solution from, I think, one house, right? And you mentioned it's open source. Are there possibilities to buy that solution? What is the trade-off here? When to choose which?
Well, so just as correction, it's not open source. It's just a free solution that they provide. So basically, it allows you to get visibility into what's happening with the open table formats. Like it tells you things like data skew, partition skew, what type of settings were picked in terms of data layout and whatnot. But these are things that you can go and figure out yourself. It's just hard to figure out yourself without some type of tooling, and it's just not an area that has been really worked on, because I really do think it's because it's the monetization, right? So a lot of open source projects, they open source the library, but they have to make money on different areas. And one area for for data storage is the ongoing operations of the data files itself. And so traditionally, it's always been that in order to get that type of statistics about how bad your SKUs are or whatnot, you have to either buy the Databricks platform, you have to either buy the tabular platform for the Iceberg guys, right? Or something else. Um, I don't foresee in the near future that people are really going to make a open source one. It's always going to be maybe a free or part of a larger suite that they offer in terms of services.
Good to know. But some use cases are better suited for one of the table formats. So which use case should we choose, or what table format is matching to a specific use case? We mentioned that Iceberg and Delta are well suited for read-heavy cases,
Yeah.
right?
Yeah. I think if you look at like the references for those two open source projects, you'll see that they're both very big into dashboarding and BI, right? And I think this is also the reason why it got popular with Snowflake, BigQuery, uh, Redshift, because I think most companies use it, the data warehouse and the data lake for powering dashboards uh, um, and that type of analytics, right? And if you look at, like, say, for instance, Apache Hoodie, their customer references are more of using transactional data lakes, right? So you look at things where, like, Walmart is using them to store. I think so. Some of it is the receipt data that they have, right? So you can imagine that there's a heavy write and there's a heavy read component to that data. You also look at Notion. You also look at their other Notion. I think Robinhood. Robinhood uses it to store is financial transaction data. Notion is storing is the data that you update inside of the client tool itself, right?
But do I get you correctly that, for example, with the Robinhood case that you mentioned, that Hoodie is sitting on the critical path of the operational data application, whereas Iceberg and Delta most of the time are sitting on the strategic analytical path of dashboard?
Yeah, yeah, and I think that's one. And I think the other thing too is that it's not to say Hoodie can't be read heavy only, right? Because it supports copy on write tables, just like the way that Iceberg and Delta uses. I think that the difference here is that it's the level of sophistication that's needed to support it, right? So I'm just saying that if you look at it from a big picture, Iceberg has less moving parts because it doesn't have to worry about these heavy write workloads. It just has to optimize for the heavy reads, and Hoodie has to do the heavy reads plus the heavy writes. And so that's why if you look at the stack and even the code base, there are a lot more components, and people are like going, well, do I really need all those components when I'm just supporting dashboards, right? And I think so companies like Walmart and Robinhood and Notion is really trying to build is a database on top of S3, right? As opposed to more of like, I just need faster Parquet to support reading this in BI workloads and dashboarding workloads, right? So it's a matter of time. It's a matter of time, and the question is whether or not the technology will go in and pan on out, right? And if you look at it of a crawl, walk, run, right? Uh, I think the large majority of the users are in, like, when they think of data warehouses and data lake is like, we're just using it to support, dashboards, and it's primarily one writer, lots of readers, right? And then you've got other companies that are building on the next generation, leapfrogging that use case into read and write. And they're like, we want to get rid of basically, we want to for all intents, maybe this is a bad way to describe it. I want Postgres on top of S3 to be able to do analytical workloads, right? Processing data that is like, terabytes and gigabytes of space, right?
But this is not necessarily bad. I mean, in recent months, there have been at least 2 plugins to Postgres that try to either use DuckDB or Data Fusion to somehow fiddle with the foreign data wrapper of Postgres to make this a reality.
Yeah, I think this is the innovation in the space, right? Because we have argued that we've argued that there's always been 2 distinct use cases, right? There is basically the columnar type of use case versus the row-based use case, right? And databases, you have to be designed for one or the other. They can't be both, right? So we've tried to do the hybrid, and it has middling effects, right? There's HTAP. It's worked in some situations, not in others, right? But this idea of like getting, an engine specifically designed for row and an engine designed specifically for column or for analytics, right? And we have this 2 distinct engines, and we let the driver kind of determine which engine to go use, right? I think it is fascinating because eventually it will come to one day is that maybe we don't need 2 separate databases. No one wants to run 2 separate databases, right? And so this idea that like the only reason why MySQL and Postgres, it wasn't designed for it to do analytical queries across terabytes and petabytes of data, right? As we throw more and more data into or the systems, basically adhere to Moore's law and become faster and faster and faster, right? They're eventually going to get to the point where they can process the data in gigabytes and terabytes very well, and then it will be now a conversation of zettabytes. Like, we need a different engine for this, right? And so we'll see. I look forward to the day that it's one database, quote unquote, one engine.
I guess for the future it will be polyglot, right? As you said, for probably 95% of the people, it will be something like smallish, perhaps single node. And then there's a couple of people that have very complex data needs, and for them it's something different, or a system that can also handle these cases.
Yeah, I would say it's so you talk about it. I think it's like the overall in the industry is the democratization and simplification of tech, right? You think about it, 75, 60 years ago, right? If you had a car, right, it was very highly technical piece of technology. Only certain people can fix it, right? You'd have to basically do, a lot of stuff. Like you have to know really about a lot of it, right? And now automotive technology has gotten to the point where, I think it peaked a little bit, maybe in the 80s or 90s, but it's gotten to the point where, most people can take care and repair their car if you buy the parts, right? And that led to the proliferation
But
of
is this
auto
true,
parts,
Albert?
right?
Like if the right to repair, people are fighting to get the possibility back, because cars are, and especially trucks and machines, are locked down with licensing restrictions, so they're not even allowed to fix it from a digital side.
Yeah. So if you look at that from a data technology standpoint, it's like used to be data was its own domain. It's very, very deep, very, very technical, and we've simplified it to the point where we get more people to go and use it, right? And so, have we reached peak, usability? I would argue not yet. Like maybe on the TP side, it's kind of like now developers kind of know how to do all the data type stuff and what they're supposed to do, or even Mongo. You know how it does a lot of these things that are automatic. And analytics right now is still a little bit further away from just someone who doesn't know anything and for them to be productive, right? And if we consolidate the database and make it simple enough, it becomes like everybody will have their own analytics system. I mean, I think that's the promise of DuckDB, right? What they're trying to go say is like, analytics shouldn't be this type of like, you don't need petabytes of data. You don't need this huge engine to go do it. You can run it in line as a process within your app. So now you're giving analytic capabilities even in small apps, right? I mean, there's even a DuckDB module for like Chrome where you can run it in line as a Chrome.
It's a WASM module that cross compiles to JavaScript basically.
Yeah, exactly. And you think about it, that was nearly impossible. If you tell someone 5 years ago that you'd have a full analytics database, in a Chrome plugin, they would be like, no, those things are like, you have to install all this special software, all this special stuff in order to get it to go work from that standpoint. Now you can basically be productive. So I think there's a whole, DuckDB, what's interesting is opening up a whole category of analytics that was unavailable to the normal developer, right? And I think that's why they get so much VC funding, because now you can basically do analytics on any single type of application, no matter how small it is, right? So this idea of like, that's going back to the whole car thing. Car used to be very specialized. Now everybody can go and fix their car. Now we're getting this reverse trend of like, all this electronics and whatnot, blah, 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 blah. And it's locking out some people. And some people want to go back to the analog world, right? Yeah. But I see this simplification, right? So this module and us as data engineers, we have to go more towards like the, specialization and complexity, just like now that, you think about it, Kubernetes has done to system admins. There are basically no more system admins anymore, right? I remember the ratio used to be said that for every 10 developers, there is one system admin. And now the ratio is like something like 10,000 containers to one admin.
But we have also the microservices. Don't forget that.
Yeah, there's microservices and whatnot, but used to be every single microservice, if you did it in the old VM world or the old way, you'd have to multiply all those, you'd have to have admins to be able to go and manage all of it, right? We're able to go do microservices because we have software-defined network, software-defined storage, software-defined compute now, to the point where we can automate it and we can scale it, right? So this idea that, when people say, okay, like DE is changing, I say, yeah, well, the whole thing, it's always changing, right? We're going to make things easier and more simple, but then we're also going to shift to, more difficult areas of engineering in order for us to go and survive. And this one right now is like, I feel like AI ML is a little bit of a black box. A lot of people are like, the tools are still not good enough, so that they still use like OpenAI. But at some point, people are there's gonna be, the secret sauce is gonna be spilling on out. And then
one question here, Albert. I mean, a similar challenge is with ingestion, right? Some people are using Fivetran and paying per record, so it can be quite expensive.
Yes.
Others are using Spark. But you mentioned secret sauce, like and Hoodie a couple of times.
Yeah.
What are the tricks that Hoodie is pulling off to make this efficient?
Efficient, yeah. So that's a good point. So I would say that for most people, so when you look at a traditional database, OLAP database, there's three major processes that happen. One is ingestion, the second is transformation, and the third thing is query, right? And most database vendors will tell you that you want to be able to run all three in my system, right? So even though they may not be efficient at doing ingestion or efficient at transformation, they sell the idea of simplification. So, hey, just run it all three, just pay for the cost, even though you might not be efficient. And people like, usually complain like I have to provision all these new machines to keep up with ingestion, even though my query is much more smaller and whatnot, right?
It's the topic about Snowpipe, right?
Yeah, yeah. I didn't want to name names. I didn't want to name names.
Ah,
Right.
okay.
and so yeah, you have this situation that happens, right, with this vendor, right, complain about it, right? So the smart guys basically say, okay, we're going to break up the three processes, and we're going to find the cheapest technology to implement ingestion and implement transformation, and maybe just use some query engine to only just do the query part, right? So, to be honest, this is what One House's business model is based on, right? It's this idea that says, "Hey, we know that the cheapest way for us to do ingestion is through Spark jobs, right? Because it's cheap, everybody can go kind of do it. You can get EMR, you can write your own files. Some people do it; they just go and import, and they'll just write Parquet files left and right, right? So it's very cheap to go do it. So that's why Spark is the cheapest to do ingestion. Spark is also the cheapest to do transformation. And then for querying, the secret sauce here is that a lot of them are highly optimized. So whether or not you're talking about Snowflake, BigQuery, DuckDB, they're very highly optimized for just the querying part. So it's really hard for you to go and say, oh, is there a better engine to do querying? Because we all kind of know Spark SQL sucks. Spark SQL is definitely not the fastest. It's probably the slowest of every single way to query SQL in a system itself, right? And so how do you get optimizations specifically in the index and the transformation, right? So if you were doing Spark, right? So where are the gaps in Spark ingestion? So I would say the first one is auto scaling, right? So if you use any of the Spark operators, right, it doesn't really understand is CPU utilization, memory utilization, whatnot. So there are definitely areas to go and optimize in that area. And you'll actually see a lot of people, there's a lot of thinking around how to right size the Spark jobs, the Spark, drivers and instances from that standpoint, right? So that's a part of the magic secret sauce, right? You have to go figure out. The second area I would also say is multiplexing. Multiplexing is the idea of taking a single you know ingestion and be able to divide it by X amount of parallel jobs to go and write all that data all at once, right? And so how well you do multiplexing is a huge indicator of how fast you can go and do ingestions, right? Some people can spend a few hours on it, and some people can spend months to make a good multiplexer, right? That will be a big change. The third thing is how it writes and how it interacts with table services, right? So say for instance you have these multiplexing jobs. Now you're running if you have 10 multiplexing jobs, you're running 10 Parquet files at the same time, right? And so how does the table services merge all these smaller 10 Parquet files back into one single Parquet file, right? So you've got how to go and figure out on that. And this is really the multi-writer type problem, right? uh, and you have to ask whether or not different open table formats, how do they support multiple writers, and how do they organize the data back into one whole cohesive thing. Like for instance, what this different TP is, in TP you write data unordered, and we use indexes as a way to make it ordered. But for OLAP systems, analytical systems, typically data is written ordered some way, right? We always talk about it like a partition key, right? So this could be time ascending, this could be a customer and time ascending, or some combination of it, right? So you have to write this data this way because basically we use partitioning as a poor man's way of doing indexing, right? Now, there are interesting work that's done on this area to do real type of indexing, like the way it's done in the TP world, in the AP world.
But you don't mean the liquid clustering of data breaks here, right?
Yeah, I mean, well, I should say, I should say that there are multiple ways to skin that cat, right? There are multiple ways to go achieve it, right? But everybody kind of knows that writing data ordered in the system is great until you need to change the query pattern. And then it becomes very painful when you have to rewrite terabytes and petabytes worth of data. But we don't have this penalty in the TP world. In the most Postgres and MySQL world, we don't have any of that problem. We just throw up a new index, right? And somehow, the index makes it easier for us to go and find this data, and we don't have to rewrite this data, right? And so I think there are a lot of smart people that are working on this type of problem in the AP world, right? Whether or not what will happen, it's really unknown. But I think this is the part of harmonizing the TP and the AP world, right? Because when you're writing from MySQL and Postgres, you have to think of data slightly differently than writing into Snowflake. And that's why it's always like a different skill set, right? The DEs, they always talk about, like, we have to do all these transformations, and then the developers are, why do you have to do all these transformations? Why do you have to do all this stuff? It's just like it's the argument here is like you're moving data, but you're moving from maybe ship to a train and train to an airplane. Yeah, the data is the same, but how we load the data and how we move the data on off is very, very different. And there's certain type of peculiarities with how TP systems are and AP systems. They not all of the features match up correctly, right? Oh, okay. So going back to the other thing, we went off a tangent. So the third is table services, right? Then I would also say the other thing to also think about is, oh gosh, I just it just dropped off on mine because my ADHD just made me go off that other track. But if I was to summarize, yeah. So auto scaling Spark is difficult. Everybody who uses Spark knows that this is a big thing. Probably even a lot of the newer frameworks, new Python-based frameworks, are try to solve this issue, right? Second biggest thing is multiplexing, right? There's that. Then there's the third is table services and how it interacts, right? So this is how picking a cow or more, or even how the compaction works from behind the scenes, right? The fourth thing I didn't mention, now I remember what it is this idea of, if you're feeding in ingestion into transformation, right? One of the big things is, how do you know what is new data, and how do you process data incrementally, right? So the thing with Iceberg, I don't believe have this feature, but Hoodie has this feature, which is called incremental queries. And the idea here is, when you do a query, it only queries from a certain timestamp and newer.
So you don't mean the time travel, right?
No,
but you mean something like streaming semantics.
Yeah. Yes. So by you doing this, is that when you do the query again, is that you only know that this is the delta that has been done, because what essentially what you're doing is that you're only reading the top X Avro files, or the top X entries inside of the parquet. You're not looking at necessarily even maybe necessarily even all the metadata and the historical commits, or all the historical writes, right? So by you limiting the amount of data that you're scanning for, right, that allows you to go and says, hey, I am just going to only look at the top X amount of Avro files or Parquet files, and I'm going to use that to do the transformation, right? As opposed to doing a full big query and then saying, hey, I do a select statement with a where clause, and then I'm hitting, I'm hitting the full catalog, and then just pulling back that data, right? So this kind of skips a whole bunch of steps in that process. And then you can just say, oh, just incrementally process. Now, this doesn't matter in small systems because you're only looking, because the thing is, you probably have more horsepower than what you need. But when you're talking about data, that ingestion of gigabytes of data, terabytes of data, all right, maybe per second or per minute or whatever it is, this matters because now you have a very low level optimization of you just only processing incrementals, as opposed to saying, oh, just doing a where clause on the data that has changed since the last time I pulled the data. So it's like little shortcuts like that, I think, that make it that, and there's other ones that are obviously on out there, but I think those are probably the 4 top things that I have on the top of my head.
One question, Albert. When doing STD2 tiles processing, is there any, let's say, trick, assuming you are in streaming semantics and call the merge into command and you want to undo or unroll what was just merged? Is there any easy way out?
Oh, that is a good question. That's very hard, right? So I think merge into is very, very difficult because it's that, if you don't have time travel, then you can get it back to a back state, right? Then the other thing is, like, do you want to do all of it rollback, or do you want partials, right? And so um, Hoodie itself has a bunch of metadata columns in order for you to kind of be able to troubleshoot, right? So the idea there is that if you had, and it doesn't have to be Hoodie, it's just good, I think, data engineering design, is that if you can pass, you know, uh, uh, data in that says, oh, job started as this, it was started by this process, it was committed at this time, right? It was, blah, 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 blah. That way you can isolate what messages are actually being put in, isolate the specific batch and the specific process of that merge into, and then you can just back out just that those set of rows, right? Uh, it is not, there is no necessarily, bulletproof easy way. I think this is where one is like, it comes to, in baseball, it's called fielder's choice, which is like, uh, everybody has their own implementation of it, right? Own, like, opinionated design, right? I think what I've seen, especially, at working at one house, they have their own opinionated design about that. They also added on top of the merge is also quarantine, right? So not only that you are doing the merge, but how do you stop making a bad merge? You have to do data quality, and you also have to do like, how do you, so basically filter as much as you can out of it, stop, before it gets into the merge command, right? Do all the work as you can that the merge actually does it correctly, right? And how do you go in?
How does this quarantine work? That sounds really interesting.
High level wise, right? High level wise is that there's pre-processing that does in one house when the data pipeline gets provisioned, right? You can go and provide rules into it to basically scan the data, right? And I don't think this is anything unique to one house, right? You also have the same type of thing with like Kafka schema registry, right? Um, the problem is that a lot of people, when they put in data and transfer from one data system to another data system, right? As you know, like, not all the data types match, right? And so you got to have something that has something as a pre-processing up front that says, like, oh, this was varchar moving into a string or into some other type, or it's been casted into the wrong way, right? And so that, you know, you can go and, you know, isolate these records and then move them on out so that the rest of the pipeline can actually still work, right?
In the domain of analytics engineering with DBT, recently we saw SDF and SQL Mesh joining
Yes.
in there, right? This is the same theme
Yeah.
about analyzing the abstract syntax tree or the logical query planning case of SDF when you're really reasoning about stuff before executing it.
Yeah. I think, yeah. So the thing is that when you talk about, DBT and others, is that they are doing it in a vendor neutral way, using their own framework, right? And all of them are doing it from that standpoint, right? And so the question really becomes is, you know, I think it's a question of your data architecture strategy. Where do you want to bring in a new product that will go and do that for you, or are you optimizing to build something special? Like, so for instance, um, you know, if you think about something that is highly optimized, you probably don't want to call a bunch of other third-party non-native tools into your pipeline, right? So say for instance, if you're doing Spark ingestion, you probably want to try to write something in Spark that will do the quarantine and the data validation pieces, right? Because then that it would, theoretically, it would be faster from that standpoint, right?
Yes, but I mean, in the case of SQL and talking to the JDBC endpoint of Spark, you should be able to reason on the level of the abstract syntax tree or the optimizer's level of a logical plan that needs to be executed, right?
Yeah.
So given you have the right metadata, let's say protobuffer definitions or something, you should even be able to do this without any connectivity to the data.
Yeah, theoretically you could, right? I just don't know how many people actually really do it, right? And so I think this is the problem, is that this is the classic buy versus build, right? So everybody can build as a happy path very, very easily. And the question becomes, is all these edge cases, like how many companies have ever been to where they have a quarantine process, they do data quality on every single major ingestion that happens, right? And it's always a nice to have, because when we work for a company, they're not in the business, for them, they're not in the business of the best data architecture, right? They're in the business of solving the business pain problem, which is, I need the data in a certain format. Are you giving me the same format? It works. Why do we need to spend any more time on this, right? For a what if situation, right? And then you've got these other data companies and data projects and open source projects that are solving this, right? But in order to get advantage of using it, is that you have to also adhere to other philosophies of that project too, right? So it really is a balance. And then how long are you going to be there, right? So if you're at company Acme and you stay there for 3 years, you implement it, someone else has to go and take over that DBT or SDF or whatever it is, right? And that new engineer may or may not know any of that stuff, right? So it's difficult. It's difficult to plan. It's difficult to execute. It's difficult, as a manager, right? Right. As a manager, it's very difficult for you to think about, do I want my people to invest it in that time, and or versus, I know I will get ongoing support, forever ever if I buy this product. And I think that's why businesses like, IBM and Teradata are still around, is because, you can keep on swapping out the engineers, but the architecture still holds, and there is still a lot of Teradata consultants. There's a lot of IBM consultants that are willing to help you on out, right?
Or some are still in their cloud migration strategy.
Yeah. Uh, yeah. So yeah, but I do love all this. Like, so if you elongate this a little bit more, is this if you had all the time in the world and you built the best disaggregated architecture. So this is like, oh, for orchestration, I can plug in Airflow, Prefect, Dagster. For data quality, I can do great expectations for for making sure that data is being moved across the pipeline for observability, use Monte Carlo. I mean, we talk about all this, but I have not seen a place that does all of it. You know what I mean? It's like they do pieces of it because they don't have the time and funding to do all those things, right? So it's got to get up to a certain point where it's so important to the business that data quality is so important or whatever it is, and they just implement that one piece, but they don't implement all the other pieces, right? So I joke about it. It's a bad thing about us, like talking heads, and this is us talking heads. Is all the data engineering Illuminati, right? The influencers on out there. Like, our best architecture runs on PowerPoint. That's it. I mean, we draw this, and oh yeah, this is great. And then you have, like, you talk to a real person. We don't have the money. We don't have the time. We don't. What can we do? What's the easiest for us to go do? And I'm like, wow. It's like, yeah. I got no real good. I got no real good advice for you, right?
Yeah, I'm really curious how it will turn out here at Magenta. We're greenfielding the cloud migration. A couple of pieces are looking really, really good. But how it will turn out in practice, there certainly are some limitations, as you mentioned. And we will see this in a couple of months.
Yeah, it's very hard, and I think I think, but the thing is, you still have to try, right? And so the reason why you have to try is that you never know when the technology will replace yourself, right? I think there was a story of you know uh, the U.S. New England, right? Um, used to be rich because of whale oil, right? That's how we got electricity, not lights, right? It's because of whale oil. And so, cities like Boston, all the way up and down the New England seacoast, the richest people were whalers, right? And then this guy Edison comes on around and says, "We got this thing called electricity. You don't need to use whale oil anymore." And he's like, you think about it, these whalers are thinking about, these guys are idiots, right? Who would go use electricity? This is unproven. You can kill people for that. With oil, we already got, we already got people. We got give them jobs. We got everything from that standpoint, right? And this idea of technology disrupting other technology, right, is time. It's happened time and time again, right? So this idea where no one ever thought the mainframe would be replaced, right? Then you got Sun Microsystems, and then eventually to VMware, to containers, right? There's this march forward of technology, and if you're not in it, the thing is that you get left in this legacy thing. And so, why do companies like IBM still survive? Because there's still a lot of mainframes on out there. They're like, oh, it's like 30 million for me to rewrite the application, but a million to keep it up and running. And then the CFO says, let's pick the million. Let's punt it. And then at a certain point, they can't get on off. Like, they can't rewrite it anymore. You know, it just becomes part of their thing. It's just a thing to go do. And so, you as a data engineer, I think I tell this to all the data engineers, is like, you have to constantly keep up to date about what's going on, because the technology you today, like Snowflake, will eventually be legacy, right? Redshift will eventually be legacy. And they're like, but these companies, they adopt like these new standards all the time, whatever it is, right? And I said, it's the same thing as, like, yes, you've got, like, SQL has been around since the late 60s, and SQL's best strategy is they're like a cockroach. They keep on adopting enough about the newest technology to keep themselves relevant from that standpoint. But if you ask someone who's a data science person, like SQL is essentially two-dimensional array. It's data in two-dimensional array. Everything right now is an object code. Like, why are we paying this tax of converting objects down into two-dimensional arrays? Right? It's like talking English, but then we write everything in Latin. Like it's just it's ludicrous. Why can't we just talk in English and write in English from that standpoint, right? This is what the developers are thinking. Why do we have to denormalize everything from an object in order to become a two-dimensional SQL statement, right? From that standpoint, right? But anyway, so there is precedence that SQL survives from that standpoint, but there is also a lot of technology that has gone by the wayside, right? And you don't want to be that guy that's in an organization that only knows the new stuff and all the newer stuff has gone on and they're just not relevant. And people, that's why I get comments like people say like, being in IT feels like you reinvent yourself every 3 years because of how fast technology moves. And if you're not in that reinvention phase, right, you become that legacy phase. And if you become into that legacy phase and you're doing all the old stuff, right, there is someone else cheaper in the world that can do that older stuff, right?
I think that's a very true thing to say, Albert, and perhaps a good quote to close on for today.
Yes. So thank you, George, for having me talk and share my opinions. Next time we gotta do we gotta do it the opposite way.